Hello, Algebra 2. This video lesson is going to be about Chapter 1.7, which focuses, as you can see here, on solving absolute value equations and inequalities. And in the video, I'm going to cover three different types of these things that you're going to need to be able to solve. Before I even get there, though, I do want to suggest that you need to make sure you understand what an absolute value equation is. So I would recommend that you consider reading page 49, the page right before this section, as well as that first goal at the top of page 50 to make sure that you're confident of what it is that we're talking about. But we're going to focus in this video on these three types. Absolute value equations, as I've already said, plus two different types of absolute value inequalities. In one case, the x is in an expression that's less than some value, and in the other case, it's greater than some value. In each case, I'm really just building on one of the three examples in the chapter, as you'll see. So let's get going with what the chapter presents as example 1. Solve 2x minus 5 inside these absolute value bars is equal to 9. In other words, tell me what x is that would make this statement true. Well, because it's an absolute value, the total on the left could be 9, but it also could be negative 9, right? Either if negative 9 were the expression inside these absolute value bars, that would still be true. The absolute value of negative 9 is 9. So what you need to do is get rid of the bars and solve both different scenarios. So here I have written it out in both cases without the absolute value bars. In one case, positive 9, in the other case, negative 9. And so I go to work solving both. I end up finding that 2x is equal to either 14 or negative 4, which means x is either 7 or negative 2. Like with chapter 1.6, I can do a check, and I recommend that you should. Here's a quick and easy way to do that. On the left side, I've plugged 7 in, and I'm wondering, is that true that it's equal to 9? Well, 2 times 7 is 14. 14 minus 5 is 9. The absolute value of 9 is 9. On the right, plugging in negative 2. 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 9, and the absolute value of that is also 9. So those two down here are the correct answers. Your turn now. Go ahead and after hit the pause button, and after you come back, I'll show you the solution. Okay, I'm going to assume that you did that. And I'll walk you through this if you like, just to make sure, but you should have ended up with negative 2 and 10. So very quickly here. I split it apart. I decided this time, and I've highlighted it in red, not to distribute the 2. I just want to point out you don't have to distribute that 2. Instead, because the 2 is already outside what's in parens, you can divide it away. So on the left side, I now have, and I recommend that you consider this because sometimes it's faster. Now I've got 4 minus x on the left, and on the right I've got 6. And here I've got negative 6 on the right. Now it solves the way it had before. X equals negative 2 or x equals 10 are the correct solutions, but you can double check those by plugging them back in for x. All right, the second example out of the textbook is this one. This is a case where we've got an absolute value inequality, and as I say, the whole expression is less than some value. Well, whenever that happens, what you actually have is an and inequality. Remember that from chapter 1.6, just the last lesson. So what you need to do is get rid of the bars, meaning the absolute value bars, and put what you have left in the middle. So what do I mean by get rid of the bars? Well, literally, take them away. What do I mean by put it in the middle? What I mean is put it between 11 and its opposite. The opposite of 11 is negative 11. Now, like I said, this is an and inequality, and you're going to solve for x, which is between two arrows. Which means I've got to move 7 out of the way first. Go ahead and do that. I should end up with negative 18 on the left and 4 on the right, and I only have 2x now in the middle. I divide by 2, and I find that the correct answer is that x is greater than negative 9 and less than 2. I should have said or equal to in both cases. So you can always plug that in and double check that I have the correct answer. I'll just show you how you quickly would do that. Putting in -9, you would only apply the -9 to the left side, right? Because it's less than or equal to x. 2 times -9 is -18. -18 plus 7 is -11. So that is that boundary line that I was hoping for. And I'm hoping 2 is the boundary line on the right. So I plug in 2. This time I'm doing it as I say, on the right. So I've got 4 plus 7. Well, that is equal to 11. So that does check out. Those are the correct, well, that is the correct answer along the bottom of the screen. Okay, your turn. All right, I'm going to assume that you did hit the pause button. Go ahead and solve this inequality and you're ready to see the worked out solution, which is right here. This time I'm not going to step through it the whole way, but I am going to point out one thing just to make sure you notice. I gave you one to do that was more challenging than the one I just did on the previous slide, because you have to divide by -1 at this point. So make sure that you remembered to change the direction of these arrows. And as I said in class and said in the last video, generally we would rewrite this in this order because this is the order that you would see on a number line with -1 on the left and 9 on the right. But this answer right here is acceptable to me. All right, the third and last scenario. In this case, again, we have an absolute value inequality, but this time the expression that has x in it is greater than some value. This is taken right from example 3 of your textbook. In this case, you have an OR inequality. It's going to work just like what we did in chapter 1.6 when we were talking about inequalities, except that you also have to get rid of the absolute value bars. And you're going to make two inequalities. Again, I've gotten rid of the absolute value bars. What do I mean, though, about make two inequalities? Well, this is the real challenging part of this. Notice that what I have now is two identical statements left and right, except I've both changed the direction of the arrow and made that negative. So make sure that's what you're doing. Now I solve the left in the same way that I would solve the right. I should end up with 3x in the left hand of both of these problems that I'm working on. I should be dividing by 3, and I should find on the left that x is greater than 10 over 3. You might have written it as 3 1/3, or you might have written it as a decimal. And on the right, I should have ended up with, and you should have ended up with, x is less than or equal to -2. Your turn. One more time. Go ahead and hit the pause button. Okay, I'm going to assume that you did that, and you got rid of the absolute value bars and created two inequalities for yourself. Most importantly, I'm going to assume that on the right, you changed the arrow direction and you changed the sign on the one on the right. And you should have solved them all the way down to find that x is less than 7/3, and on the right, x is greater than, well, either 15 over 3 or 5. That's it. This was a pretty quick lesson. 3 different types of absolute value equations or inequalities to be able to work with. And those are the homework problems I want you to do. These top ones here, and there are only about 8 here, 8 or 9, are straight from the type of work we just did in this lesson. The bottom 8 or so here on page 56 will give you a chance to combine your work with 1.6 and with 1.7 and make sure that you're confident with both of those types of questions. Come to class with those solved and we'll be ready to hit the ground running next time.